All right, good day everyone. Welcome to another exciting lesson on chemistry with the analogous. I'll be looking at Le Chatelier's principle under chemical equilibrium. So this is a topic or a sub topic under chemical equilibrium. Le Chatelier's principle. Now, a French scientist called Le Chateliers. All right, Le Chateliers in 1884 actually looked at a system or a chemical reaction in equilibrium, studying Van Hoff's principle, and came about the principle which says that if a system is in equilibrium, and there is a change in temperature, concentration or pressure of that system. So when a system is in equilibrium and there is a change in temperature, concentration, and pressure of that system, the system will have to shift its equilibrium position in order to cancel the effect of the change that was just imposed or implied on the system. So for instance, what do I mean? I say, for instance, I have A to give B, and at the same time B gives A. So at a point equilibrium will be established. So A reacts to give B, and at the same time B gives A. At some point equilibrium will be established. Now when equilibrium is established at this point, when A reacts to give B and B reacts to give A, when equilibrium is established at this point, if I change the concentration of A, the equilibrium position will have to shift. Maybe the equilibrium will shift towards the side of V, allowing more B to be formed so that equilibrium is restored back. So the equilibrium position somehow, what I said, if I increase the concentration of A or remove A from this system, then more B will be formed, or more A will be formed in order to just restore the equilibrium back. So this was the basic principle behind the Chatela's idea, or the basic um, story behind, or the basic ideology behind the Chatela's principle. The principle, the law is sometimes called the equilibrium law, or the Brown's Le Chatelain, because Ferdinand Brown also studied this system in 1887. I'll quickly dive into it and how you can apply it to solve questions. Effect in temperature, effect of concentration, effect of pressure. They're quite simple, so we'll really look at them. So we'll start with the simplest, pressure. Without pressure, it is the simplest. Now, watch. So under the Chatelain's principle, effect of pressure, effect of pressure, effect of pressure. So effect of pressure. Now, according to Le Chatelain, pressure only affects gaseous reactants. So for you to increase the pressure of a system, it will affect the equilibrium of gaseous reactants. Now, what do I mean? So let's say H2 gas, or let me use this popular one, Albers process. So Albers process is N2 gas plus 3H2 gas. Now to quickly give me 2NH3 gas. So if you see the reactant or the product are all gaseous, so pressure can affect them. So if I increase the pressure of this system at equilibrium, remember this equilibrium can be achieved in a closed system. If you have not watched, if you don't know this, you should check the other equilibrium video, the equilibrium one video on equilibrium constant. We said all this there. So this equilibrium can be achieved in a closed system. Now, if if peradventure I increase the pressure of this system, now more NH3 will be formed, or more ammonia NH3 will be formed. Why? The reason is because an increase in pressure shifts equilibrium to the side with lesser number of moles of gases, or what directly say, increase in pressure shift equilibrium to the side with lesser volume. Now if you see the number of volume of gases here is 1 mole, 3 mole, that's total of 4. The number of moles of gases, or the volume of gases here, is 2 moles. So this side has a lesser number of moles than this side. So increase in pressure shift equilibrium to the side with lesser number of moles, just like Boyle's law. Increase in pressure, decrease in volume. So increase in pressure favors side with lesser volume. What about if I decrease the pressure of this system? If I decrease the pressure of this system, the equilibrium position will shift to the left. What does it mean to shift to the left? To shift to the left means there's a formation of more reactants. More reactants are being formed. Yes, more reactants are being formed. Yes, and just to restore the system back to equilibrium. So for instance, so what will favor the production of more ammonia? Pressure. Now, increase in pressure favors the production of more ammonia, while decrease in pressure favors the production of more nitrogen and more hydrogen. So let me try. Let me show you another example. Let's say for instance, this reaction 3Fe plus 4H2O, equilibrium established to give you Fe3O4 plus 4H2. So this is solid, this is gaseous, this state is gaseous, and this hydrogen is gaseous. Now, this solid reactant, pressure won't affect them. Yes, pressure won't affect them. So pressure only affects the gaseous reactant. So consider the gaseous. So how many moles of gaseous reactant are here? 4. How many moles of gaseous reactant are here? 4. In case you don't know why it is 4, the gaseous is 4, the gas here is 4. These ones are solid. No, don't say 7 and 4 or 7 and 5. No. So it is 4, 4. So an increase in pressure or a decrease in pressure, we have no effect on this system. So no, this system, no effect. So if I increase the pressure, I decrease the pressure, you also have no change in equilibrium position. No, nothing is more formed. No reactant is more formed. Now, let me try another simple one. So for pressure to just be clearer, I will use SO2 gas plus O2 gas to give me 2SO3 gas. Yes, so this is 2 balance. So there are 2 moles here, 2 moles of SO2. So now, for instance, now I'm going to ask you, now, if you see, how many moles of gases are here? I'm going to ask you now, how many moles of gases are on the left hand side and the right hand side? Now you should answer. Now let me help you out. Now the number of moles of gases on the left hand side is 3, 2 here, 1. Number of moles of gases on the right hand side is 2, or the product side is 2. So an increase in pressure will shift equilibrium position. An increase in pressure will shift equilibrium position to the side with lesser number of moles or lesser volume. So lesser number of moles is the product side. So increase in pressure will favor the production of more SO3, shift equilibrium to the right. While a decrease in pressure will shift equilibrium to the left because it has a higher volume. So decrease in pressure will shift equilibrium to the side with higher number of moles of gases. So decrease in pressure favors the production of more SO2 and more oxygen, while increase in pressure favors the production of more SO3. Yes, it's that simple. Now, we'll look at the effect of temperature. We'll look at the effect of temperature. So the effect of temperature. Effect of temperature. Look at the effect of temperature. So quickly, looking at the effect of temperature. All right, for the effect of temperature, we have to know 2 things. Yeah, for an equilibrium, how does temperature affect equilibrium position? We have to know 2 things. The first thing we have to know, is 2 types of reaction when it comes to temperature. Now, the 2 types of reaction when it comes to temperature are exothermic reactions and endothermic reaction. Exothermic and endothermic. Now, when I mean exothermic, for equilibrium reaction, it should be noted that, for instance, A to give B. Now, if delta H for this reaction is plus Q, so let's say Q is a number, so it means that the forward reaction is endothermic. The forward reaction. So when the forward reaction is endothermic, is what I'm referring to now. So, but let me just explain to you. When the forward reaction is endothermic, because delta H is positive, the forward reaction is endothermic. It means that the backward reaction is exothermic. The forward reaction is endothermic. It means that the backward reaction is exothermic. Yes. Yes. Now, what of if we have a minus Q here? What does it mean? It means the forward reaction is exothermic and the backward reaction is endothermic. But basically, I'll be considering just the forward reaction to just work with temperature, to just to make you easily arrive at a value very fast. So I'll be working with temperature. So now I'll quickly do this. Though it is fixed, I'll quickly do this. I'll go back to my Albers process again. Now, N2 gas plus 3H2 gas. Now equilibrium, I have 2NH3 gas. So delta H is minus, let's say 564 kilojoules at this point, minus 564 kilojoules or minus 564 kilojoules per moles. So now, if you ask me, this equilibrium reaction, the fourth reaction is exothermic. Now, for exothermic reaction, increase in temperature shifts equilibrium position to the left, favoring more reactant formation, while decrease in temperature shift equilibrium position to the right, favoring more product formation. That is a fixed thing that normally occurs. It is fixed. Now, but let me quickly explain easy ways for you to quickly get them, or I'll call it a simple trick or an arc. Now, look at it. Now, before I tell you that arc, though we've not looked at concentration, you should note one thing. Whenever you add in an equilibrium reaction, if you add more product for an equilibrium reaction, if you add more product, you will produce more reactants just to come back to equilibrium. Yes. And if you add more reactants, you will produce more products just to come back to equilibrium. So I add more products, I will produce more reactants. I add more reactants, I will produce more products. That's how we will treat temperature. Now, for you to be exothermic, it means that you liberate heat. For you to be endothermic, it means that you absorb heat. So, I can rewrite this thing and say N2 gas plus 3H2 gas. Now, equilibrium to give me 2NH3 gas. Now, for it to be exothermic, it means that it is being liberated. So when it is being liberated, I add it to the product side. Yes, it is temperature, it is liberated. So it is exothermic, it is liberated. This is what I mean, it is liberated. So you can say plus it. So it's just my simple arc, my shortcut, as we call it here in. Now, for my simple arc, now we treat temperature as if it's a reactant. Now, what do I mean? Now, for it to be exothermic, for a reaction to be exothermic, it means that it is liberated. That means on the product side for exothermic reaction, when the charge is negative, always put plus it here. So now let me give you briefly about concentration. Now, if I talk about this, if I talk about concentration, or if I explain concentration with this, it's very simple. Now, concentration is two-way sided. Now, effect of concentration, though I will talk about it after this temperature. Now, let's say we have 50 of the reactant and 50 of the product. That's why it is equilibrium. They are in equilibrium, so they are just interchanging. Now, and you added two. Please watch. You added two products. 50 you add 2, so it makes it 52. So we have 50 plus 2, 52 now. Total of 52. The reactant has 50. So what should happen for equilibrium to be restored? For equilibrium to be restored by increasing the concentration of the product, that means adding more product. For equilibrium to be restored, it means that some of the reactants have to be formed. That means some of these products have to now react because they are now more in number than the reactants. So it has to now react and form more product. What do I mean? So we are now going to transfer 1 to it, so it will now become 51, so that this one will become 51, restoring that initial equilibrium state. So for equilibrium reaction, increasing the concentration of the product, means more reactants will be formed. Also, in the same way, increasing the concentration of the reactant, it means that more products will be formed. As simple as that. Now, what about decreasing concentration? That one is a little bit complex. Now, for instance, we have 50-50 equilibrium, and I remove 2 from here. Let's say I remove 2. So remove means decrease. So I decrease the concentration of the product. I remove 2. So now we have 48-50. So I've removed 2. A concentration of 2, or I've decreased the concentration by a factor of 2. So if since I've decreased concentration of a factor of 2, I have distorted equilibrium. That means this system is no longer in equilibrium. So what will happen now, because I decrease the concentration of the product to just come back to equilibrium, some of the reactants will now have to react and form more products. That means now some of the reactants, these 50 have to now reduce to about 49 and form more products. So decreasing the concentration of the product leads to the formation of more products. It was 48 after you decrease concentration, so it now increased to 49 coming from the reactant. So decreasing the concentration of the product, decreasing the concentration of the product increases the, what's it called now, decreasing the concentration of the product increases the formation of the product. That means to shift equilibrium position to the right. Okay, what about decreasing the concentration of the reactant? So retaining our initial equilibrium position 50-50. Now I decrease this one by a factor of 4. So now we have 46. Now we have 50. Yes, 46-50. No, we are no longer in equilibrium. We have decreased the concentration of the reactant. So how do we come back to equilibrium? We come back to equilibrium by the formation of more reactants. How? It is now obvious that products are more than reactants. So we have to come back to equilibrium. How do we come back to equilibrium? So these ones we have to now decrease. Now to now decrease to about 48, and that 2 will be transferred. 2 of them will be transferred there. So the 2 will be transferred there, and here will increase by 48. So it was 46-50 before, it was 50-50, decreased by 4, it was now 46-50. So in order to come back to equilibrium, 2 was not coming here. So if you decrease the concentration of the reactants, more reactants will be formed, or the product will react more to form more reactants in order to restore the equilibrium state to 48-48. So it is simple. Increasing the concentration of the reactant, increasing the concentration of the product, increasing concentration of the product, increasing the amount of product. For this reaction, adding more NH3, we favor the production of more reactants, N2 and H2. That means shift equilibrium to the left. Adding more reactants, adding more N or adding more H, we shift equilibrium to the right, favoring more products. Yes, or favoring product formation. What about all right, now decrease in the concentration of reactants we also increase the formation of more reactants. If you follow my explanation, increase in the concentration of of more products, increase the concentration of more products, we also favor the formation of more reactant. Favoring the formation of more reactant means shifting the equilibrium position to the left, while decrease in the formation of more reactant, please learn it, decrease in the concentration of more reactant favors the production of more reactants. So if you decrease the concentration of more reactants, that means if you reduce the concentration of the reactant, more products will react and form more reactants. So shifting the equilibrium position to the right. Also, increasing the concentration of products, we also shift the equilibrium position to the right, favoring the formation of more reactants. That's increasing the concentration of the reactants, we will shift the equilibrium position to the right, favoring the concentration of more products. Pardon me, favoring the concentration of more products. Yes. So how will that be a hack, or how will that be a simple hack to solve problems that involve temperature? So like this, we are done with concentration. So I already use temperature to explain concentration. So how would that be an hack to this? Now, how would that be an hack? It will be an hack to this problem in the sense that if heat for exothermic, I told you once it's exothermic, what you just have to do is just to put heat here to the right hand side. I'll treat for endothermic. So heat to the, so exothermic means that the first reaction is exothermic, that means heat is being liberated. So just add heat to the product. So how does that affect? So how does that affect, or how is that an hack? Now, since product heat is not a product, if I increase the concentration, if I increase temperature, it means I have increased heat. Yes, if I increase temperature, it means I have increased heat. So if I increase it means I have added more product. I've added more. If I add more products, if I add more products, it means If I add more product, it means that what's it called? We have more product than reactant. So in order to come back to equilibrium will be shifted to the left, favoring the production of more reactant. Yes, increasing the concentration of products, increasing the concentration of products shifts equilibrium to the left. Yes, increasing the concentration of products shift equilibrium to the left, favoring more reactant formation. So increase the temperature for exothermic reactions like increasing heat on the product side. So it will shift equilibrium to the left. So what about decreasing temperature? Decreasing temperature. Decreasing temperature means reducing heat. So if I reduce the amount of product, if I reduce heat, which heat is not a product, of course it's exothermic. If I reduce it, it means that more product will be formed in order to just come back to equilibrium. So for exothermic reaction, increase in temperature, shift equilibrium to the left, favor more reactant formation, while decrease in temperature, shift equilibrium to the right, favoring more product formation. Now, what if the reaction is endothermic? So let me use another reaction. So let's use this simple reaction. Let's use for NO plus O2 to give 2NO2. So let's say delta H is equals to plus 200 kilojoules. So 2. So what does this mean? What does this mean? What does this mean? Now this simply means something. This simply means something. It means that 2NO plus O2 to give me NO2, pardon me, plus heat. That will be wrong. Why is it not plus heat? Because it is endothermic. It means that it is absorbed. Now, when it is absorbed for endothermic, the act is simply add heat to the reactant side. Yes, add heat to the reactant side. So it is endothermic. That means absorbing heat. The reactants are absorbing more heat. Yeah, so that's why it is endothermic. Before reaction is endothermic, it means that the reactants are absorbing more heat. So yes, like that. So if I add it to the reactant, it means that it is not a reactant. So for endothermic reaction, it is not a reactant. For exothermic reaction, when the equilibrium is general exothermic, or when the forward reaction is exothermic, it means that it is a product, like the previous example. Now it is endothermic, it is not a reactant. So when it is a reactant, increase in temperature means that I've increased more reactant. It will now shift equilibrium to the right. So now let's learn it. For endothermic reaction, if you have your pen now, right? For endothermic reaction, increase in temperature, shift equilibrium to the right, favoring more product formation. Now, what about I decrease temperature? If I decrease temperature, it means I've decreased heat, remove heat. Now I remove heat, making the reactant less. So what will happen? More product will react to form the reactant back. So decrease in temperature shifts equilibrium to the left. Decrease in temperature shifts equilibrium position to the left, favoring more reactant formation for endothermic forward equilibrium reactions. Please take note of that. It's that simple. Now, I would like to give a general example. Since I already explained concentration, temperature, and pressure, I would like to give a general example. So let's take this process, a simple equilibrium reaction in the contact process. A simple equilibrium reaction in the contact process. So now let's say delta H is 250. So negative 250 kilojoules. Now, what will increase the yield? What will increase the yield of SO2? What will increase the yield of SO2? What will increase the yield of SO2? So now quickly, the yield of SO2 is increased. Please take note. The yield of SO2 is increased by, now what will increase the yield of SO2? A reactant. SO2 is a reactant. So what will increase the yield of SO2? Now there are three things that can affect it: temperature, concentration, and pressure. Now, so in terms of pressure, in terms of pressure. Now pressure increase in pressure pressure. Now if you observe, pressure favor increase in pressure favor the side with lesser number of moles of gases. So they are all gases, pardon me, they are all gases, so pressure is going to affect them. So let's say we have gas. So how many moles of gas are at the left hand side? 3, 2 plus 1. How many moles of gas are on the right hand side? 2. So increase in pressure shift equilibrium to the right, favoring more SO3 production. So SO2 production is favored by decrease in pressure. So the first thing is decrease pressure. So decrease pressure or decrease in pressure favor the production of more SO2, a reactant. What about temperature? What about temperature? The reaction is exothermic. Reaction, the fourth reaction is exothermic. And I told you an increase in temperature shifts the equilibrium to the left for exothermic reaction. You don't know, I shift the video backward, you will see why. So it means that what will favor the production of more SO2, a reactant, is increase in temperature. Increase in temperature. Increase in temperature. So increase in temperature will favor the production of more SO2. It's exothermic. Increase in temperature for exothermic forward reaction. Increase in temperature shift the equilibrium to the left. Now, what will favor the production of more SO2 in terms of concentration is increasing SO3 concentration. So if I increase the concentration of SO3, if I increase the concentration of a product, more reactants will be formed. So at this point in time, we'll call it a day for this video. I remain analogous. Now, I would like you to subscribe and share this video with your friend. I know it is very helpful. Make sure you use it to learn any video you want, any topic you want in chemistry, A level, O level, you want us to trash in biochemistry, biology also, just write it on the comment section, giving you challenges. I will do a video on it. So I'll see you when I see you next. Have a nice day.